Oh, nice. Cool. I'll start tweeting and sharing and taking photos.
Do you mind clipping that one on? That's the one that the world at large
World
can
can hear me.
And then that's how loud you talk, whether you actually need a microphone.
Yeah.
I never use a microphone because I shout.
Yeah, I'm pretty vocal.
Yeah.
I think the microphone kind of gives me something, a lifeline to hold on to. But it's not. We'll see. I don't know. There doesn't seem to be too many people. I'm sure I'll be able to yell at everyone. Might just grab a Coke before we start.
Whatever you need now,
Excuse me, I'm just going to steal a Coke. Everything's good.
Oh, thank you.
I think this is just connected to the stream, not to the speakers. But
There's that other mic if you want to.
yeah. We'll see. I'll see how full it gets.
Should we try and get this up?
Yeah, that'd be great.
Yeah, there was a plug. I just needed to unplug.
Hey, anybody listening online, we are going to be starting at 6:30. And if you're watching in the future, you won't hear this because I'll edit this bit out. Catch you in a few minutes. Okay, perfect. If you talk too loud to me right now, they'll hear you online. So he's not saying anything. All right, we're going to be starting in 1 minute.
What's the kind of normal format for like length of time, questions at the end, like
45 and 15?
45. That's kind of what I've been going for. Yeah, perfect.
We figure we're all clear downstairs. It's 6:30. We should just go. We're already 15 late. Should we do our normal things? You want to run up there and rally? If you want to be online, just Glenn. We didn't do this last time, and it sounded like garbage. Just hand it off.
Is everyone up?
Just make sure that if there's anyone else
Okay, welcome everybody to the DSO London Gathering, April edition. If you'd like to come take your seats, those of you online, if you'd like to grab a beer. So welcome everybody to our April edition of DSO London Gathering. Thank you for coming. We've gone a week earlier than normal because next week is obviously KubeCon. We didn't want to clash with that, so a number of us are not going to be around next week. So yeah, thank you for coming a week earlier, and thank you Investigo for hosting us. So this is us. In fact, this is 3/4 of us now at the moment. We have another new person to introduce you to. So yeah, we've got Jess, Steve, myself, and we also have Frankie. Yay. And if you want to get in touch with us individually, this is how you get a hold of us individually. If you want to get hold of us as a group, then on to the next slide. This is how you do so. We've got a website, dsolg.com, which Frankie's hopefully going to help us update. And if you want to get in touch with us, the best way to do it is through our email. That's team@dsolg.com, and all of us get that email, so any one of us can respond to you, and we're pretty good at responding very quickly. Obviously, our Meetup page, that's how you found us, and we also have a LinkedIn profile. YouTube, this is being streamed live, but it also appears on our YouTube channel afterwards, so please do check out our YouTube channel where you find a lot of different videos, and the podcast.
Oh, no, new slide.
Oh,
Yeah. Surprise.
oh, it's a surprise, Steve. What's going on?
Frankie made it.
Frankie made this slide. So stay tuned for our May event. So join us on Wednesday the 17th of May. So we go back to our third Wednesday on the 17th of May. Well, details will be coming soon.
And
So the DevSecOps Overflow, that's our DSO Overflow. That's our podcast. The latest edition actually is an interview that Steve and I did with Michael, our founder, who's out the back there, sporting a new shirt as well. But yeah, do check out our podcast. The last one was a really good podcast that we recorded. Learn a little bit more about the background to DSO, and yeah, we just enjoyed it, and I hope you do too. Big shout out to some of our other events. So London DevOps is one of our more popular ones. I see Sam was here from, oh, well, here he is, right at the front here, for OWASP. So OWASP, if you've not gone to one of the London chapters yet, then please do check it out. When's the next one, Sam?
Probably end of May.
Probably the end of May.
Yeah, we just had a capture the flag event, so
Cool.
I'm planning the next
There was
one.
a shout out we need to give you 30 seconds.
Yeah, 30 seconds.
Yeah. So hi. So I'm Roy Harrow. I'm from the BCS DevSecOps group. So similar organisation, similar aims. We have an event on the 27th of April. We need to get our name up on your board. So I'll send the information through 27th of April. Go and have a look on Eventbrite. And the way to find us is BCS DevSecOps group on Google. Wonderful. Thank you. Thank you for your time.
Oh, thank you. And I think I now hand over to Steve.
All right, I have to do all the sponsor shout outs. That's for my sins. Our gold sponsor, Sysdig. Sysdig is, I know them for their open source contributions. I think they're a great organization. They have things like Falco that do wonderful things for observability and security. And they also have a platform called Sysdig that you can go check in. Additionally, wait, one more. Prisma Cloud, it'd be hypocritical if I didn't say I actually work there. But secure infrastructure applications, I work in the open source team. I don't work for sales. So, you know, if you want to talk to somebody about buying that, I have no clue. And then new gold sponsor. We have a gold sponsor. We stole this from their website. Fixed with context, released with confidence, secure cloud application with complete visibility. If you want more information and that doesn't make any sense to you, Simon is here. Where's Simon? He's at the back taking a photo right now. He can tell you all about what Apera is and what they do and what all they stand for. Another excellent sponsor. We're very happy to have on board. And of course, a big round of applause because they're here. Investigo for giving this amazing venue. The booze and the food at the back. I mean, it's incredible. Investigo. David, do you want to say anything? I'm a little quiet?
Yeah.
Okay. That doesn't happen very often.
Do you want me to teach you how to project your voice?
Please come. Oh, good. Off you go. Show us how it's done.
Hi guys, welcome to the Investigo office. As always, we're proud to host the DevSecOps Meetup. If you don't know about Investigo, Investigo is a recruitment and consulting business. We do everything from permanent hires to contractors and interims and project-based teams. My team specifically focuses on cybersecurity, hence why we're working with the DevSecOps guys. So if you want to talk about jobs in the market, any specific trends or new opportunities, or you're hiring for your team, you can give me a shout or grab one of the guys in the team. There's a few of us here this evening. And yeah, that's all from me. Logistics, if you need the bathroom, they're just round to the left behind me. Exit, if you do leave, you might have some trouble getting back in. So if you wait till the end, the security, you'll be able to get out at the end of the evening. If anyone you know is stuck downstairs, just let me or one of the guys know and we can go down and get them. I know we have a few people that like to show up late. But that's all for me, and I'll pass you on. Cheers, guys.
And lastly, I'm not sure which
Same
mic
time.
to, both of mics at the same time.
Yes, please.
Amazing. Hi. So I've chatted to a few of you about this today, but if you want to be a speaker, or if there's a topic, a DevSecOps specific topic that's particularly close to your heart, we'd love to hear from you, provided I can stay standing. Please send us a bio, send us like just a summary. If you've just got a couple of lines, that's enough, and we can kind of work with you. We've got a little form as well that's on our Twitter page and our LinkedIn, but essentially we'd love to hear from you. So keep those talk submissions coming. But for tonight's talk, so GitGuardian's done some really interesting research over the past year into leaky secrets, or secret leaking rather. And Mac is here to talk to us all about that. So I don't want to delay any further, but Mac, if you want to do the honors. Can you put this- Oh, okay.
I've got one. I have my own mic.
Sorry.
I'm good with tech.
We good?
Now you're good. I'll put it
Okay,
back. All right.
great.
Perfect.
Awesome. I was probably sitting on it. So yeah, I work for an organization called GitGuardian. So we kind of specialize in code security, and we're pretty focused on finding secrets inside code. I'm going to talk a little bit about that. I'm going to talk about some research. Mostly tonight is going to be about some research that we've done into the topic of basically finding and exploiting secrets and how we can do this. So a good place to start, I'm probably sure everyone's aware, but I always just like to put in a quick definition of what are secrets, what am I talking about, so everyone's on the same page. So pretty much I'm talking about digital authentication credentials. So typically these are things like your API keys, your credential peers, your security certificates, anything that authenticates you, or more importantly, authenticates a machine into your systems. So these are really the crown jewels of any organization. And when we look at attacks, secrets are often used in different ways in multiple different attacks. Once an attacker or an intruder gains initial access, one of the first things they're going to do is try and find secrets. Why? Because it means they can move laterally into different systems, they can elevate their privileges, they can persist their access. So it's really one of the first things that they will do. And I'm going to run through some examples of attacks later on, and break down exactly how the attackers were able to use secrets in different parts of kind of that attack vector. All right, so how do we use secrets? This is probably another basic slide, but I'll just race through it. So we have our modern applications now. Right? We've moved away from the monoliths. Well, most of us have. So what does this mean? This means that our applications are now built up of lots of different microservices. So if we think about it, we might have Okta for our authentication. We might have Stripe for our credit card processing, Algolia for our search. Maybe we're using SendGrid to send out messages, or whatever it is. We're no longer needing to build all of these services individually. We can now offshore it to these different areas. The problem is that each one of these communicates with our application through secrets. And every one of these is an access point into our infrastructure, into our data. But once we've built our application, we need to host it somewhere. So now we have infrastructure, and we have to store our code somewhere. We have to host our application somewhere. We have to run CI/CD pipelines to test our code. All of this also leverages secrets because we need to send data through everything. So now we have more access points into our application, into our infrastructure. Then once we get the application going, the pesky marketing and sales teams, they want you to build dashboards and other things. And then we end up with more secrets and more stuff that we're connected to. And we haven't even talked about the microservices that we create internally. So this is a very simplified version. In reality, it gets much more complicated. But our applications are a collection of these services. It becomes very, very complicated. And it's very hard to keep track of everything that you're using as much as we try. And all of these are kind of leveraging secrets in different ways. So we now have lots of secrets that we need to manage for our application. Different teams need different secrets. So we have this problem where secrets need to be securely protected, wrapped in lots of authentication layer, and they should be tightly controlled with very limited people having access to them. But they also need to be distributed to everyone. So this is where kind of secret sprawl comes into it, because these secrets need to be used by people, and the tighter we protect them, the harder they are to get, so the more likelihood I'm going to make a clone of one on my machine. All right, so quick overview of secrets. We can move on to some of the other stuff. So every year GitGuardian produces a research project called the State of Secret Sprawl. So this year we've done it for the last 3 years, and this year we had some really interesting results. And essentially, we are monitoring public places where code exists, or containers or other assets, and we're scanning them to try and find secrets. And we publish the results of how many secrets that we find. So there was a giveaway in the title of actually like how many secrets we did find. But one of the main places that we look is this website here. Now, this is GitHub. The largest code sharing platform on the world. It's got the most amount of source code, therefore it's very interesting. Now, as an organization, you might not have any exposure, or you might not think you have any exposure to GitHub. Maybe you use Bitbucket or GitLab as a version control system. You don't have any open source projects, so GitHub doesn't concern you. But the problem is that your developers probably do use GitHub. In fact, I'm almost certain that they will, because GitHub is kind of like almost used as LinkedIn for developers nowadays, because you have to have portfolios, you're probably managing other open source projects. So you do have exposure to GitHub through your employees. And that's significant. I'll come back to why that's significant. So some interesting stats on GitHub. So how big is it? So GitHub claim 94 million developers are using the platform. 1 billion commits were made last year. So a commit, if you're not familiar with, this is a contribution. It's basically uploading a segment of code, publishing it on GitHub. So over 1 billion commits, these are just public commits, were made last year. 85 million repositories were made. So this is really, really a huge platform that's got lots of information, a literal fire hose. And what we did at GitGuardian is we actually scanned every single one of those billion commits for secrets. So if you've committed anything to GitHub, we monitored it. Now, you may be wondering how we did that. I'll explain that later on. We don't have any relationship with GitHub. It's not illegal, and attackers do this too. So we're not doing anything really technical, and you'll be surprised how easy it is to actually monitor GitHub. So what did we find? So we found 10 million secrets in 2022. Throughout the year of 2022, we found 10 million API keys, credential peers, security certificates. Now, some of you may be thinking to yourself, okay, maybe they just found 10 million high entropy strings or some random values, and we're very confident we've broken down exactly the types of secrets that we found, and we also validate them. So if you leak an AWS credential, we'll check with AWS that that's a real credential before adding it in. So when we say we found 10 million secrets, we really found 10 million secrets. So it's a very scary number that we had. So how does this compare, or how does the trend kind of show compared to other years? So we first started doing this in 2020. We found 3 million. Last year, we found 6 million. And this year, we found 10 million. So we've got a clear path going up. Now, this isn't explained entirely by everyone just getting worse. The amount of code going to GitHub increases about 20% every year. So some of it is explained by the fact that we have more code going in there. We also get better at what we do every year. So our detections are refined. We capture more secrets. We introduce new detectors. So a little bit compared. But if we look at kind of the closest thing that we have to oranges, apples to apples comparison, is that out of every 1,000 commits that we scan, we find about 5.5 secrets. I don't know how you find a half secret, but yeah, we found 5.5 secrets for every 1,000 commits. That's an increase of 50% from last year. So we are showing that there's definitely an increase in the amount of secrets that are being leaked. And we can kind of speculate a little bit about why this is. And some of the reasons is that the attack surface and what we're turning into code is expanding. So, of course, when we build our applications, they're built in code. But now we've also introduced things like infrastructure as code, GitOps and DevSecOps and other areas where we're codifying parts of our operations. We're codifying and managing parts of our infrastructure. So that means that we're using more and more, we're managing more and more things with code. Those things need secrets. So we're leaking more secrets. There's more secrets to be leaked. And the scariest number out of all this report is the 1 in 10. So I said at the start, there's 94 million developers on GitHub. That's GitHub's numbers. 14 million published code last year publicly. So still a big number, but not 94 million. But 1 in 10 of those leaked a secret throughout the year. So that's a huge amount of people. You have an organization with 100 employees in there, and that means that 10 of them probably leaked a secret. And you could say, no, but our employees are good. These are clearly just junior developers. These are probably just dummy secrets. It doesn't matter. There's definitely not what we've found. There's lots of examples where real secrets have been leaked in GitHub that are belonging to organizations. And it's not just junior developers that are doing it, because senior developers have access to more secrets. And I'll talk about some mechanisms of why this happens. But actually, when you see it explained, it makes a lot of sense why secrets get leaked in this way. All right, so this slide here, it looks interesting. I personally, I think this slide is useless. I'll explain why. So these are like the countries that leak the most amount of secrets in the world, but it's also, you can see that it's kind of like just, it's basically just a population of how many developers a country has, in my opinion. So China has a lot of China and India have a lot of developers, so they leak a lot of secrets. So, but it looks scary, so we included it. But it does show that it's a worldwide trend, right? The one thing that this slide does show is that there isn't any really standouts. And when we create this slide kind of per, kind of base it, per person, and average it out a little bit, the slide gets very boring. But I take this slide with a little bit of a grain of salt, but it does show that this happens all around the world. And there's not any particular place, in my opinion, despite what this graph is kind of saying, that actually leaks the most amount of secrets. But it is still interesting to kind of see that there isn't anywhere that kind of stands out as being abnormal on this. So what type of secrets did we actually find? So I said at the start that we're able to identify what the secrets are. So we don't have one detector that's looking for high entropy or looking for specific type, or looking for kind of general API key equals value. We have individual detectors. So we have about 350 individual detectors that are looking for specific keys. So every time someone makes a commit, we scan it with at least 350 different scanners to try and find AWS keys that are specific to that. Stripe keys have a specific detector, etc. So this gives us pretty good accuracy. And then we also have generic detectors that use entropy statistics to try and find it, and also some post-analysis. I won't get too much into the dorky stuff, but the number one key that we find, this other category is kind of everything else. So we have a very long tail of secrets. Most of the secrets that are linked are kind of within a small group, and then we have a very long list of other secrets that are there. But the ones that are predominant are very interesting. So data storage, around about 25%. So a lot of data storage keys. So this could be something like an Amazon S3 bucket, could be a database. So this gives access immediately into information that could be interesting to an attacker. Cloud providers, this one's really scary, so 20%. So well over a million, 2 million, in fact, cloud provider keys were found in GitHub publicly last year. So you don't need to be a genius to kind of know what you can do with a cloud provider. If you don't have a lot of imagination, the very least thing that you can do is create some crypto mining or use the computing power. You could launch DDoS attacks, or basically if I can hijack someone else's cloud account, then I can do nefarious things and not have to worry about the consequences. So that's 2 million credentials there. There's a lot of credentials, right? If you're an attacker, you're never going to be short of cloud provider keys. If you're smart, you'll never have to pay a cloud provider to launch an attack in your life. Messaging systems are really interesting. Why? Because one of the most common specific types of keys that we find are Slack bot or Slack webhooks and things like this. The reason that we kind of draw to this after we do some research is that a lot of people kind of create side projects of making a bot for their Slack channel or Discord channel that does something. When I get an email, alert me in my work channel. And they open source that and they accidentally leak a key. That's usually a key to a work like server or a work messaging system. At its most basic level, is all that key allows me to do is post something in a Slack channel. Then I can at least create internal phishing campaigns that come from an internal system, which makes it much more believable. So they're still very, very interesting. And if I can read messages with that, then we know that secrets get shared a lot in Slack channels as well, passwords, so I can find a lot more stuff. Private keys are my favorite. Version control platforms. So this is basically people publishing their GitHub tokens to access their private GitHub repositories in public repositories. In fact, we found 500 commit messages where the commit message was the GitHub authentication token. So it's kind of like sending an email where the subject is your password. We find lots of weird stuff. If we want to look at specific credentials, the number one key that we find is Google API keys. Google Cloud keys are up there as well. API keys factor into this. Remember, we have Google Maps keys included in this, Maps API keys. So keys have levels to them. Google Maps API keys, yeah, you can run up a build. You can't do much else. But Google Cloud keys, you can do a lot with. GitHub access tokens, we find an awful lot of them. AWS keys and lots of others. And we have a very long tail, so it gets very messy when we start adding into it. But we really find all kinds of keys. We find Bitcoin wallet access, crypto wallets access credentials, and all kinds of really fun stuff in there. So let's have a talk about when is this actually, how do attackers actually use this information? Can attackers use this information? So GitHub is like a fire hose, and there's secrets everywhere. So when have secrets that have been exposed publicly actually caused a data breach? So these are the incidents that have happened just last year, and I'll just focus on one, which is the Toyota one. So we can see what happened, because this gives an idea of kind of the risks that you have. So what happened? So for the Toyota breach, it was actually a key that was available in a public GitHub repository for 5 years. It wasn't leaked by Toyota. It was leaked by one of their contractors. It was for an application called T-Connect. And this is a mobile application for Toyota car owners that could do lots of cool stuff, like start your car for you. And it had lots of information in it. And a contractor that was working on that application with Toyota accidentally created a public repository, and they pushed the keys to that public repository that gave access ultimately to the database of all the users in there. So this is quite serious, and because it was available for 5 years, you really just have to assume that someone has found it. Eventually, a security researcher found it and notified Toyota, and then they had to disclose the breach. But this is an example. I like this example because it really kind of shows how in a large organization you can be affected through GitHub, even if you have no exposure to it. There. Now, there's also lots of other examples. I'm sure you're all aware of the SolarWinds breach. So I have to lay some disclaimers in here. That's why I don't have a slide on it. But in September 2019, we know that threat actors gained access to a SolarWinds FTP update server. They were then able to turn the SolarWinds software malicious, which then got pushed down the chain, and attackers were able to put backdoors into lots of organizations, including the US military. Now, it could be a coincidence, but also in September 2019, an employee of SolarWinds leaked access credentials to the FTP update server on a public GitHub repository. So SolarWinds have never said if that was the initial access point, and to be honest, it was a very sophisticated attack, so there's more components to it than just having the credentials, but that could have been one of the initial footholds into it. So it happens to lots and lots of different organizations in lots of different ways. All right, so how do you find keys on GitHub? So there's a few ways. This is probably this is one way. It's the least interesting way, in my opinion, but it's the easiest, so I have to talk about it. So this is called GitHub dorking, and essentially it's using the GitHub search feature. In fact, there's been some updates to make this easier. In this case, I'm looking for a file called credentials, and inside that file, I'm looking for an AWS access ID. And you'll get lots. Now, not all of them are going to have access keys in them, but I have a lot of results. I have 18,000 results, and so I can sift through that. And there's lots of different types of kind of dorks that you can do that you can set up. Now, this isn't very interesting. The reason why I find this the least interesting is that what's on the top level on GitHub is really just kind of the tip of the iceberg. Where we find most of the credentials are actually in history. So something that's been committed over. You've got a developer that's working on a feature, and they've said, hey, I want you to connect up with this Algolia. I want you to build this feature out. And the first thing I'm going to do as a developer is just build a proof of concept for myself that I can connect to these services. I get the keys, I hard code them in, I get it working. I do some more stuff, and later on, I remove those keys and make them environment variables and handle them correctly. But the keys are still in the history. And then when it goes to a code review, you don't look through every change that when someone sends you, a draft to check, do you check every version of that draft? No, you look at the latest version and you edit it from there. Same with a code review. You're not going to go through every version of the history, so it gets merged in, and then you have keys in your history that no one ever really saw. And even the developer probably doesn't understand that that's a threat. Searching doesn't look in the history. So that was a long way of saying why that's not There's a much better and easier way of doing it, and that's thanks to the GitHub public API. So all you need to do is go to api.github.com/events. You don't need any authentication. You can call this 60 times in an hour with no authentication, and it's very easy to create multiple GitHub tokens if you want to call it more times than that. And from here, we're looking for lots of different events are published here, but we're looking for two in particular. The public event, this is the most interesting. This is when a private repository is made public. Along with that private repository, the history is made public with it as well. So you may have checked that repository, there's no keys in there, but on some obscure branch 3 months ago, 1,000 commits deep, a developer committed some AWS credentials, now they're public. The other area is the push event, which is when code is pushed into a repository made public. So these are the two events that we listen for, and some others, but these are the main ones. And it's really easy. Anyone can do this. In fact, if you leak a honey token, like a credential that's a dummy, it will be exploited within a few minutes once you push it to GitHub, because there's endless amounts of bots that are just looking on this to try and pull the information out. And that's basically how we scan it. Now, so all of that looks at public repositories. And public repositories are fun to talk about because it's public. I get big numbers like 10 million secrets, we're all going to die. But the real drama and the real issue is actually what happens in our internal private systems. So at GitGuardian, we scan internal systems for large organizations. If we take a very average size organization, one with about 400 developers, so not that big, but also not tiny, what do we find? We generally find on our initial scan, we'll find 1,000 unique secrets in their source code. Of those secrets, generally speaking, there'll be about 13 occurrences. So let's say 13,000 secrets total that we will find on average in an average size company. So that's a lot of secrets. That same company probably has 4 AppSec engineers. 1 AppSec engineer per 100 is around about the industry standard, maybe a little bit above, maybe a little bit below. But if we assume that, let's say that those AppSec engineers now have visibility onto all of those secrets. They know about them all. What do they need to do now? Well, they need to communicate with the people that leaked them to find out what they are. They need to rotate them because they're a security risk. They then need to replace them. And they need to do this without causing any downtime. And they need to do it 13,000 times or around about 3,500 times each every year. So if that's all that you did as an AppSec engineer, and there's 4 of you, you're still not going to be able to do that in an entire year. So it's just better to ignore the problem and hope that it goes away. But our internal infrastructure is really kind of causing a lot of headaches. And the argument to that is that, yes, but it's private, right? We have private source code. We have multi-factor authentication on our repositories even. So you're doing well there. So why is it a risk? The problem is that source code is very, very leaky. It's probably backed up into multiple different areas. It's cloned onto all your developers' machines. Developers themselves have access to it. And we can see by the amount of secrets that they leak that they can be a bit of a security risk. It's probably in wikis. It's shared on Slack messages. So your source code, even if it's locked down, isn't going to stay that way. It's going to sprawl into it, and you have no visibility over it. There's no logs that let you know where your source code is or if it's kind of left the Git repository. And we've seen endless amounts of source codes that have been leaked. So just last year, we had the Lapsus group at the start of the year really go on a rampage. They leaked the source code for NVIDIA, Samsung, Microsoft. LastPass has its source code access. Dropbox had its source code leaked. So there's endless amounts of headlines of where source code has been made, let's say, involuntarily open sourced. And so along with this comes with it all the secrets that were shared. So in the case of Samsung, we scanned the source code. We found 6,000 credentials inside Samsung source code. Judging by the size of it, it's actually pretty good. That's below the standard of what we would expect. So Samsung were actually doing it right, but it's still 6,000 credentials in it. Twitch had about the same. They were in last year's report, so they're not on here, but Twitch had about 6,000 repositories when their source code was leaked as well. So we can't guarantee the fact that our private source code is going to stay private. And there's lots of different ways that this can happen. It can be nefarious, and it also can just be an accident. In the case of Lapsus, a lot of people wondered, how did Lapsus manage to do this? How did this kind of group of what we later found out was kind of teenagers access these great companies like Microsoft, like NVIDIA, that have good security posture? How did they access their source code in the first place? And the answer is pretty boring. They purchased credentials from the dark web forums, and they paid employees of those companies to give them access to VPNs and repositories. They didn't do anything fancy. They just paid for it. So this kind of goes to show that, hey, do you have one developer out of 1,000 that's had a really bad day, that's got an insurance claim or something they need to pay for that will just take $4,000 to connect up someone to your repository? So this is why we can't really trust that our source code is really going to stay secure. And the other area is just through mistakes, misconfigurations. In the case of Twitch, it was a misconfigured server that was publicly accessible. It didn't remain publicly accessible for very long, but in the short time where their Git repositories were accessible to anywhere due to configuration, then it was accessed by a malicious actor and they leaked it. So it's not always kind of malicious. So let's have a talk through some of the attacks that have led to credentials being exposed inside internal networks and internal systems. So Uber last year had pretty much the worst case scenario that I'll explain. So this one here was, it wasn't officially the Lapsus group, but it was done by an attacker with ties to the Lapsus group. They purchased a credential on the dark web, and that was for the VPN. The VPN had multi-factor authentication. So you would think that Uber was good in this case. However, they spammed the MFA, and they also called the user of the account pretending to be the security team. The user granted them access on the application or told them the code, and they had access to the internal network after that. The first thing that they did once they had access to the network was start scanning and enumerating all the data to try and find secrets, because they know that their access won't last. Their access is dependent on no one finding them, so they want to try and find more secrets to persist their access. They found the mother of all secrets in a PowerShell script, which was an admin credential to their PAM system, their Privileged Access Management System. So a PAM system is like a secrets manager and a password manager rolled into one. So what did this PowerShell script do? Well, basically, when a new employee from Uber joined the company, someone had to sit behind the desk and create huge amounts of accounts for that person. So they automated that part of their job, which I have no problem with. That's smart. But by automating it, they needed to have access to the secrets that could kind of create these accounts they needed, and they hard-coded it into the script. So that script was basically there to create a bunch of accounts for new employees. So what did the attacker do when they had access to this key? They created a bunch of accounts. They created accounts for themselves in the AWS, GCP, Google Drive, their Slack, SentinelOne, even their HackerOne, so all of their tools. And this attacker, in this case, was really just after notoriety. So what did they posted in the Slack channel of Uber immediately, let everyone know that they had hacked them and that they had been pwned, but they could have done much more nefarious things. They could have persisted access into there, remained hidden in the background. They could have sold access to someone that wanted to do something much worse. You never know. So worst case scenario ended up being okay for Uber because the attacker wasn't all that bad in this case. Here's another one. This one is a little bit older, but it kind of shows a bunch of different things. So it's, yeah. So how did this attack? So I don't know. Let's start. What is CodeCov? Here we are. I've found my train of thought. What is CodeCov? So CodeCov is a code coverage tool. It sits in your CI/CD pipeline. It does a very specific thing. It tests how much of your application is being tested. It's a great tool. I still would say it's a great tool. It's not that critical, and you wouldn't really think twice about putting it into your CI/CD pipeline. So what happened? CodeCov was mostly being run from a Docker image. That Docker image was their official Docker image. It was hosted on Docker Hub, which is basically just a place that you can get containers. Inside that Docker image, there was a hard-coded credential that was in plain text. It's quite common. About 5% of Docker images that are public have hard-coded credentials accessible. This credential gave access to, it says Git there. It was actually a Google Drive that had a bash uploader script. This bash uploader script was being used by some customers to automate certain parts of it. They had read-write access. They were able to update that bash uploader script, and they injected a malicious line of code. That malicious line of code did one thing. It said, every time code conv is run in the CI/CD pipeline, I want you to dump all the environment variables, and I want you to send them to me. So in a perfect world, when you're testing your application, you use a different set of credentials and secrets than your production, hopefully. That's still bad that those testing credentials are being leaked, but there's some that you can't really do much about. And one of the main ones is like your VCS, your version control, your get access tokens. In this case, the attacker was really after one thing, which was GitHub access tokens. And they were able to move from Docker, from their Google Drive, and then into the private repositories of CodeCov's customers. Now, there was a lot of people who were affected by this. Twilio, Monday.com, HashiCorp was also affected, and attackers were able to access their private repositories. Now, I very rarely pick on a company that's had an attack because I genuinely believe they can happen to anyone. But I do pick on one company when I talk about this, and that's HashiCorp. The reason being is that HashiCorp creates, in my opinion, one of the best secrets managers on the market. It's called HashiCorp Vault. It's a very heavy, it's a very good product. They created the term secret sprawl, and all of what they do is about making sure secrets don't end up in your Git repositories. HashiCorp had to disclose that they had secrets in their Git repositories that the attackers accessed. So if HashiCorp have secrets in their private repositories, the rest of us have absolutely no hope. So that's it. But so that just goes to show an example of how someone else can leak a credential that can be used to manipulate, turn their application malicious, and then gain access into the private repositories of other users. Now, none of those users did anything wrong, apart from maybe having secrets in their repositories. But that's why we have to assume that our source code can be accessed and will leak, because there's a very good chance that it will. Just a quick slide, we're coming here. One of the other things that we looked at this year is infrastructure as code vulnerabilities. So I mentioned at the start that we're expanding what we're codifying, which is expanding the attack surface. The fastest growing language is HCL, which is a HashiCorp infrastructure as code language. We also scanned any repositories that were related to infrastructure as code, so templates to release things, lots of different examples here. We found about 21.5% that had vulnerabilities. Now, it's very hard to kind of definitively say that and what you could do and how critical is each vulnerability without really researching each project. But around about 40% of the 20% had at least 1, 2, or 3 to more. You know, we still have 20% of repositories that had 3 to 5 infrastructure as code vulnerabilities in there. So this could be something like a misconfigured S3 bucket, which is allowing remote access. Or it could be using HTTP instead of HTTPS. I don't know why you would do that, but lots of different things. So as we're moving to infrastructure as code, you know, this is another area. Now, I also mentioned that one way that malicious actors can kind of get into networks and private code repositories is actually through misconfigurations. It happened with Twitch. It's happened with lots of S3 buckets and areas like that. So that can be an initial access point to try and find more secrets in there as well. How am I doing for time? Okay, so how do these secrets get exposed? So we kind of talked about the history things where you're testing out secrets. It's in a development branch, you forget about it, you replace it, and it's still there. So that's one way that really definitely contributes a lot to secrets. The other area is private repositories being made public. History is another big contributor to this as well. You know, it's very common that a private repository that no longer needs to be private is turned public. I'm a big advocate for making things public. The message of this talk shouldn't be that we should have less public things. It should be that we should have more public things, but understand them. Secrets are often in logs and generated files. So if you have a debug log, it might contain environment variables. Those environment variables could be secrets. And if you do something like git add all, something like that, then those logs can get captured if you don't have correctly configured git ignore files, and that's inside your repository now as well. We see a lot of really sensitive files in Git. The number one file that we found is .env files, environment variable files. By design, these are sensitive. They should never be inside a Git repository, but it's the number one contributor to secrets. So an easy way to fix that is a git ignore file. But we see a lot of those. And again, it's kind of these wildcard git add all. It's a Friday, you're going for beers, let's just add everything and push. And then accidentally pushing code to the wrong repository. This is kind of an interesting use case, especially for GitHub, is that often if you're using GitHub for your work, you'll often have one account for both your personal and your professional use. So it's very easy to configure a wrong remote if you have a shortcut set up, and then you push something that's meant to be for a private work repository into a public personal repository. It's not super common, but it definitely happens quite a lot. So there's lots of different ways, and there's more ways that they get exposed here, but when we're talking about source code and Git, these are definitely some of the main contributors that can cause that. So how do we prevent this? So the first thing is kind of assume we breach and assume your source code will be made open source. If we adopt this posture, then it changes how we think about it. It means that, hey, if we're going to be breached and our source code is going to be breached, then let's think about it as if it's open source. Can I open source this software tomorrow and sleep easily? That should be the standard that you should achieve to. And then while you're there, you might as well just open source it. Using automated secrets detection. So I work for a vendor, so I won't talk about why we're the best, but I'll be happy to answer that in private. But there's lots of secrets detection tools out there. There's open source ones, Trufflehole, Git Leaks. There's enterprise ones like ourselves for large organizations. So it's a low barrier to entry to start using automated secrets detection, even just to put them in your CI/CD pipeline and to build your way up to having it throughout your software development lifecycle. The barrier to entry is low for secrets detection. Some elements of zero trust. So just because an API key is zero doesn't mean you have to grant everyone that has access to it to your systems. So especially if a system is meant to connect to another system, limit the scope of that API so that it can only connect to that one system. Limit the IP address range. So don't, and definitely don't make it live forever. So we should be using short-lived credentials. We need to rotate credentials regularly. And the best benefit of rotating credentials regularly is the fact that we actually know how to do it. So when we do have an incident, we actually know what credentials are for. We have policies in place. We know what they're targeting. So if we're rotating credentials regularly, we actually know how to do it. It's going to make life so much easier in the event that your source code does sprawl. And it may not be that maybe no one's accessed it, but you still need to rotate those secrets, and now you know how to do it. Honey tokens to identify breaches. Honey tokens are my new favorite trend at the moment. These are, they're very easy to create, something like a fake AWS credential. There's an open source tool we just created called GG Canary. And basically it just creates up to 5,000 fake AWS credentials that do nothing but alert you and give you the IP address of the person trying to use them. So you can put them all in your infrastructure, put them in your repositories, and then you know if it's been leaked, and then you know if someone has access to something that they shouldn't. Segment your development environment, so make sure you're not using production credentials for anything to do with testing in your CI/CD pipelines, and start scanning if you're using infrastructure as code. If you're not, use infrastructure as code because it will help in terms of making things much more dependable and repeatable. And then we should be doing security scanning, at least basic security scanning on infrastructure as code to make sure that we don't introduce any of those vulnerabilities. And that's it from me. So I think we have some time for questions, but oh, thank you. You can clap. Yeah. Yeah, question? Yes, we do. So not with all secrets, because we can't with all secrets. For instance, if it's like an RSA key, we don't know what that's for, or if it's a username password pair, But if it's something like a AWS credential, a Stripe key, anything along those lines, then we can just make a non-intrusive API call to check that it's valid. And then what we also do is we use that in our marketing will say machine learning, I won't, like our algorithms and our classification algorithms, we plug the information back in of whether or not something gets deleted quickly. So if something is leaked, we check that it's real. and then we find out that it's been rotated after we've alerted to it, then we know that that was a valid credential. So it helps us improve it. So we do, and I think it's about 30% of the detectors that we can validate on. So not all of them, but some. Yeah.
Does this work with Azure DevOps?
Yes. Yeah, it does work with Azure DevOps. Yeah. So we can do, so GitGuardian, to talk about the company a little bit, we plug directly into your version control system. So Azure DevOps is one, Bitbucket, whatever main one you're using. If you're using SourceForge, then you've got other problems. But Azure DevOps, we can connect in natively. But then we can also connect into different areas, like in your CI/CD pipelines, or we can put in something like a Git hook or a blocking request that actually will prevent it. So kind of what we say is, to start with, and this is the same for any tool that you use, not just GitGuardian. Start with is detect secrets in your repositories and then stop the bleeding. So like understand your risk, then put in some places like Git hooks and other areas what actually stops more secrets from coming in. So then you can get on top of the problem, because otherwise you're kind of chasing your tail a bit. Oh yeah, sorry. Yep.
How are this and how are they made available to the developer community? Is it like as they get detected, is it get published in the workflows, or how is it published?
How do we alert when we find something? Yeah, so we have a pro bono alerting system. So all of those secrets that we've found, we try and identify an email address of the developer that leaked them, and then we send them an email with just the information about that, hey, we think you've leaked a credential here. So that's kind of an email. How we do that is through the Git metadata. So if you go onto GitHub and you find a Git commit, if you just add .patch into the URL, then you can see the metadata, and then in that will be the locally configured email address that person can. It's also published on the GitHub API. So if we have an email address, if we find that, we do it. We don't publish anywhere else when we find credentials, because we don't want to alert anyone. We don't create like a GitHub issue or something like that, because we don't want to publicize the fact that we've found a credential. Oh, so when in terms of the product, then yes, we have dashboard. We have a couple of products. So one product is kind of you connect into your repository, and there's lots of stuff and analytics and all kinds of great graphics design that I'm sure helps in some way. So you can see all that, and it also kind of, once it connects in, it does lots of cool stuff. Like it will communicate with your developers and send a survey, like, is this secret valid? Can you rotate it? What's it for? And then so your team has access to all of that from the dashboard. One of the cool things that we can do for enterprises is we actually, because we've been monitoring GitHub for so long, we have created maps of who works for what organizations and employees. So essentially what we can do is, if someone from Microsoft leaks a credential on their personal GitHub repository, then we know that that person works for Microsoft, and we can alert Microsoft to that happens. And there's a dashboard for that too. But that's kind of getting into some enterprisey stuff. In general, just the pro bono alerting, if you have an email configured, we'll send you an email if you leak something, and do our best to try and help you mitigate it the best we can.
One more thing, in terms of prioritization, suppose the secrets are there, but actually it's there on a non-public facing application, or the priority of that, there's no impact, there's no risk basically. So is there some way you prioritize, because the developers would be overwhelmed in prioritizing and taking up for remediation?
So the question was, can we prioritize, I guess, incidents from something that's public to something that's private, or a different? I would argue that there's definitely a risk if it's private, but I understand what you're saying is that a public AWS key is much higher risk than a private AWS key. And so yes, we do. On the dashboard, we let you know if it's public, and we can automatically assign severities to it. So a Stripe key is much more severe than a Google Maps API. And then so once we plug into your system, you'll have thousands of secrets. You can prioritize immediately from critical, which is anything that's kind of public and grants access to your systems, and then you can work your way down. So we do prioritize the incidents. Yeah, I mean, definitely shouldn't be out there, but yeah, for sure. I mean, a cloud key, a database key, let's start there, definitely. And yeah, you absolutely can, so that you can start that, because that's a big problem. It's like, where do you start? I've got 6,000 credentials to remediate. Where do I start? Whoa. Okay,
Question on false positives, because
Yep.
so one of the problems when you're searching for secrets,
Mhm.
you find a lot of false positives. Actually, your slide number 1 has a false positive, because instead of the actual AWS key, there was a variable which was called AWS key, not the actual value of the key. And obviously, from my experience as an AppSec professional,
Yep.
whenever I work with a tool, whatever the tool is,
Yep.
commercial or free, 90% of it is usually noise.
Right.
And it, for us, it takes a lot of time for AppSec professionals to obviously sift through the noise and say, okay, that's just some, I don't know, GUID, so it's not a password. This is a label saying enter your password. This is a variable. Maybe one out of 10 is actually where. So first off, is false positives in there, or they've all been checked that they're not false positives, because that's a huge amount of work.
Yeah.
And sort of a part 2 of it, you didn't mention how to address the problem of false positives.
Okay, so the question here is really about false positives. I'll shorten it just for the streamers. How can we be sure that the number I'm presenting is actually correct? Because there's lots of noise in these things, and how do we address that problem? So the first thing is we have to kind of separate the categories up. So we have specific detectors, which, like for something like a Stripe key, Algolia, something, we can check that they're real. So they're a fixed length, they're a fixed character. It doesn't matter if it's called API or Stripe API equals, we're looking for the character set, and then we can verify it, so we can tick it. All right, they're the easy ones. The hard ones are the generic detectors. So what we can't do is we can't tell you if the generic detector is valid or not valid. But what we do know is that it is a valid key. So we do this through a number of different ways. So we train our algorithms on the GitHub data. We have 7 years of it. And so our generic detectors, we have about a 70% true positive rate, 30% false positives. We have areas where you can go into paranoid mode and you can get to see all of it, but it comes down there. So how do we do that? Well, we do post-validation on the actual kind of code that we find it in. So we identify a high entropy string. 90% of high entropy strings are not secrets. The unique identifiers, the URLs, their images, whatever it is, they're not secrets. So then we find them, and then we do post-validation on that to try and find information in the source code or in the repository of what this key actually does. And that's based on years of scanning and kind of what we have. How we also can benchmark it is we do a lot of benchmarking in our public service, because what we do is once we find a secret, we monitor what happens to it after we've alerted. If that repository disappears, if that secret goes, then we know that was a false positive, and then we can kind of check back in, and then we run those through the algorithms as to why that was. So we're getting closer and closer to true positive. And we've always been really good at this, but open source tools and other tools are also getting much better at it, because we're getting bigger. We're training our things on data set. And when you look at things like ChatGPT and AI, you can see how those language models are being trained, and we can train secret detection. So we're never going to get to true positive in the sense that, is this random API key actually valid or not? But we can get rid of we can get rid of a lot of the noise from it, but not 100%. And you'll have to try and let me know if we do reach that 70% benchmark. I can see skepticism in your eyes. All right. Any other questions? Yeah.
Is it possible to completely scrub your Git history?
You can do. I'm going to say no. You can do like Git squash. You can squash your history, right? But this, like, Git is finicky in how it handles everything. And one of the things that Git is really good at is making sure that if you make a really big mistake, if you haven't messed with anything too much, that you're going to be able to reverse that. So even when you squash your history, there are ways to try and get that back. I wouldn't say that that's like completely safe. It kind of tidies it up a little bit. So There are some things you can do that if you really want to get rid of your history, the best thing to do is just to create a new repository, and move the code into there. And then you're going to be safe. But in terms of other ways that you really, and I'm not a fan of scrubbing history because it's important that we can go back, and it's important that a year's time I can say, hey, why don't we change everything to Golang, and then I go back and they started doing that and they failed. I don't know, whatever it may be, right? So I like having the history, but so there are ways, but I don't rely on that. Rely more on changing the practices of it. Yeah. Yes.
Thanks. So just wondering, do you have any sort of capabilities around pre-commits?
Yes.
That's more proactive nature.
Yeah. Yeah. So we have like a kind of a rollout plan. Like once we roll out, connect in, find out where your secrets are, find out what they are, add it into your CI/CD pipeline, and then definitely add pre-commit hooks. We have a tool called GG Shield. It's an open source tool, and it can add a pre-commit hook really easily. Pre-commit hooks you can't rely on them because they can be easily bypassed by the developer. You can do like blocking merge requests and things like you can do more intrusive stuff, but ultimately the number one thing that you want to have is visibility in your repository so that you can see that, and then definitely set up as much areas as you can, but you can't rely on it because like I'm a developer. I know what I'm like when some useless thing pops up in front of me. It's get away. No, bypass. Yeah. Yeah.
You check the metadata and are there repeat offenders? So are developers learning from their mistakes, or actually is there a set of developers that just keep them making
So I don't really know. I don't really know. Like we don't have like a leaderboard in the office. So I'm like, oh, John, bloody John is at it again. But we do have customers that have a wall of shame on there. So that and one of the cool things is the tool is that you can see like what teams are leaking the most amount of secrets and all of that. That's not to shame anyone. It's just to kind of lean into the competitive nature of developers and engineers to try and because once you have a wall of shame, no one wants to get on that. Like your security posture is going to skyrocket. So there are things like that, but I don't know particularly if but I'm sure there are repeat offenders from this. Yeah.
Quick one on those stats. Is there any kind of trends or analysis on the size of organizations and in terms of the percentage of the people that are committing these secrets out there?
So publicly or kind of privately? That's my mind.
Well, like, are they?
Are
you finding it in startups? Are you finding it in larger enterprises?
Okay, well, like what area? Yeah. So honestly, we've tried to do analysis on this, and we really find it everywhere. Like there's some keys. There are some trends that like a junior developer will definitely do. Your first time creating a Django project, you're going to have a Django key in your public repository. It's just going to happen. But then in the size of organizations, we really find it everywhere because you have so many different people in organizations, and it's really easy to do it. One of the best kind of engineers that I know has a hilarious story about leaking secrets because he was working for Algolia at the time. His wife was pregnant. She went into labor. He just quickly like, oh crap, time to go to the hospital, get pushed, get at all, off we go. Came back 2 weeks after maternity leave and found out that he'd pushed admin credentials publicly to the AWS account, like in a panic. And he's brilliant, he'd be like, of course you don't put secrets in it, but you just never know what's happening. Everyone can do it. So we don't really have stats on really the kind of the size of and when we're talking about public companies, the microphone's dying. When we're talking about public companies, there's a lot of domains and secret projects in public companies, so it's hard to get a full picture unless you're working with the company, and then you can kind of capture everyone in that because there's a lot of different areas. So we don't see a lot of leaks from Microsoft or from Google, and I'm going to assume that they're just really good companies, but they could also have hidden domains that we don't know about that and actually they're leaking lots of secrets. I doubt it, but yeah. So yeah, we don't really have stats on that entirely. So yeah, oh yeah, oh yeah.
I'm still in the question for both at the back.
Oh, at the back. Oh,
yeah. He's not asking. He asked if I'm thinking I'm being clever, or perhaps I'm involved in Kubernetes and I'm base 64 my secret. Do you see it's base 64?
Yes.
Decode it and then validate it.
Yeah, we decode like what we can. If you've like fully encrypted it, then we obviously like we can't. But if it's base 64, we decode it and then find the information from that. Yeah, yeah. Yes.
If you're tracking all this info from GitHub, do you notice that there's like a drop in leakage from people who start using actions in a particular way? Like, is there a trend in platform use?
We haven't looked into that. It's interesting. I think like maybe we should kind of see. I don't know. I'm not sure exactly how it would kind of go about sorting all that information, but it would be really interesting to see like at what point. I'm sure we have some stat out there. It's like once you use GitGuardian, you never leak a secret, or something like that. But apart from those kind of stats, we're not that bad. I should lay off the marketing team. We're not that bad, but yeah. Yep.
I was just going to say, actually, I'm one of those statistics. I got a notification from GitGuardian.
Yeah.
I forgot to put the don't ignore on the Terraform state.
Yeah.
It picked up the SAS token for the storage account.
Okay, cool.
The SAS token. And I thought it was pretty good, actually. It sent me an email to my account, told me exactly where in the file the token was. So, yeah.
Nice. I'm glad. Yeah.
Welcome to the club.
Yeah. I've done it. I was making a video of what happens when you leak an AWS credential in public GitHub, and I leaked the wrong credential. I was meant to leak the dummy one. I leaked the real one. Like I've done it. And then I got a notification from GitGuardian, and I was like, luckily I looked at it and it was like valid. That was weird. Yeah. Was there another one?
I think again related to the prioritization. So suppose there are like the applications affected. Do you also have a provision to add application criticality in the UI? Because that will help us in further risk prioritization.
I'm not sure if we have. You can sort through like applications or like repositories. So you could like if you have a critical application, you can just see the secrets in that application. In terms of like a general dashboard, I can show you the dashboard and show you it. I don't think that there is like a way there where you can say this application is critical, move up. We do have a functionality called playbooks, which is basically a way of like if then that kind of information where you can say actually that would probably be able to do it. Like if it's from this type of stuff, assign this severity. So there would be a way to do it. Not from the application level, but from what we call our playbooks, which controls like automatically assigning severity. So yeah, I can show you afterwards if you want. Yeah, for sure.
Doing it?
Great.
All right, big round of applause.
Thank you.
Done. Glenn, what are we doing next?
Okay, so